Have you ever wondered how astronauts survive in the harsh vacuum of space, where there is no air, no protection, and temperatures swing from extreme heat to freezing cold? Picture this: a human floating in the vast emptiness of space, relying on a suit to keep them alive. It sounds like something out of a sci-fi movie, but it's reality. Astronauts depend on something truly remarkable to protect them from the dangers of space: spacesuits. These suits are not just high-tech uniforms. They are life-saving systems, an astronaut's lifeline in the void of space. But how do they actually work? In this video, we're about to embark on a fascinating journey to uncover the secrets behind these life-saving garments. From their history to their design and their incredibly intricate components, we'll delve into how spacesuits are engineered to withstand the unforgiving environment of space. We'll explore the challenges astronauts face when stepping out of their spacecraft and how these suits make those dangerous walks possible. We'll also discover how these suits have evolved over time, from the early days of space exploration to the cutting-edge designs used today. It's a story of human ingenuity, survival, and the unyielding drive to explore the unknown. By the end of this journey, you'll have a new appreciation for these seemingly simple garments that are nothing short of extraordinary. So, let's dive in and take a closer look at how spacesuits work and how they keep astronauts alive in one of the most hostile environments imaginable. Imagine the moment an astronaut steps out into the cold, airless void of space. One of the most monumental human achievements, traveling beyond the Earth's atmosphere and into the vast expanse of space, requires not only incredible spacecraft and cutting-edge technology, but also one crucial piece of gear: the spacesuit. The suit is designed to protect astronauts from the harshest conditions, ensuring their survival while they venture beyond Earth's comforting atmosphere. This might seem like something out of a futuristic film, but in reality, these suits have been vital to astronauts' safety since the dawn of space exploration. When we think of spacesuits, we often picture a shiny white suit, like the ones worn by astronauts on the Apollo missions. But these suits have come a long way from their first designs in the early 1960s, with each generation becoming more advanced, more specialized, and more essential to human space exploration. Spacesuits are as much a part of space missions as the spacecraft themselves. When you think about it, they're almost like miniature spacecraft, self-contained environments designed to protect astronauts from the most extreme conditions. Space itself is an unforgiving place, a vacuum where there's no air to breathe, where the temperatures swing between 250 degrees or 157 degrees in the shade and 250 degrees, 121 degrees in the sun. Without a suit, an astronaut wouldn't survive for more than a few seconds. And yet, these suits enable astronauts to not only survive, but perform extraordinary feats of exploration. The first spacesuits were designed in the 1960s, coinciding with the space race. In 1961, Russian cosmonaut Yuri Gagarin became the first human to travel into space, aboard Vostok 1. At that time, astronauts didn't venture out of their spacecraft, and the design of the suits was relatively simple. However, the historic 1969 Apollo 11 mission to the Moon marked a critical turning point. With Neil Armstrong and Buzz Aldrin set to step onto the lunar surface for the first time in history, NASA knew they needed a suit that would provide more than just basic protection. They needed something that would allow astronauts to work, move, and even survive on the Moon's barren, hostile surface. The Apollo suits, known as extravehicular mobility units, EMUs, were complex and bulky but effective. These early designs marked a huge leap in human space exploration, with engineers overcoming immense challenges to make sure astronauts could survive and thrive outside their spacecraft. But as technology progressed, so did the need for more advanced, lightweight, and flexible suits. As NASA set its sights on the International Space Station, ISS, in the 1990s, new challenges emerged. Astronauts would need to perform spacewalks for hours at a time, conducting repairs and experiments in low Earth orbit. And here we are today. Spacesuits have become even more sophisticated, more specialized, and more life-saving than ever before. The spacesuit of today isn't just about survival. It's about ensuring astronauts can do their jobs in space. They're designed to allow astronauts to move, work, and even survive in extreme environments. Each space mission presents new challenges, and each new suit has to meet those demands. But What goes into making a suit that can protect astronauts from the dangers of space? How do these suits function to provide breathable air, control temperature, and withstand the immense pressure of space? How do engineers solve problems like microgravity and radiation, all while ensuring astronauts can move freely? These questions are at the heart of the next chapter of our story. So, stay tuned as we uncover the incredible engineering and cutting-edge technology behind spacesuits. The journey into the fascinating world of spacesuit design is just beginning, and it's bound to answer some of the most mind-blowing questions you've ever had about space travel. Space is one of the most unforgiving environments known to humankind. There's no air to breathe, no atmospheric pressure to keep the body intact, and temperatures fluctuate wildly between burning heat and freezing cold, depending on whether you're in direct sunlight or shadow. Then, there's the ever-present threat of space radiation and micrometeoroids, tiny, high-speed particles that could puncture a suit in an instant. For astronauts stepping outside their spacecraft, their spacesuit isn't just clothing. It's their entire survival system, a personal spacecraft wrapped around their body. But designing a suit that can protect against all these dangers while still allowing for movement and dexterity, that's a monumental challenge. Let's break it down. If you've ever seen footage of astronauts performing spacewalks outside the International Space Station, ISS, you've probably noticed how slow and careful their movements are. That's because their suits, while incredibly advanced, are still bulky and stiff. Unlike on Earth, where we have gravity to help stabilize us, astronauts in microgravity have to rely entirely on their suits for pressure, oxygen, and temperature regulation. The question is, how do you create something that can provide life support, mobility, and protection all in one? To understand the complexity, let's take a step back to the early days of space exploration. When NASA began developing spacesuits for the Apollo missions, they quickly realized that one of the biggest challenges was pressure. Here on Earth, we don't think about atmospheric pressure because we're used to it. But in space, where there's no air, the body needs an artificial environment to prevent bodily fluids from boiling away. Early pressure suits were designed with rigid, inflated layers that provided the necessary pressure, but they severely restricted movement. Imagine wearing a fully inflated balloon around your body. Every step, every motion would require force just to bend your limbs. One of the biggest breakthroughs came with the Apollo A7L spacesuit, which used multiple layers of fabric, metal, rings, and flexible joints to allow astronauts to move more naturally. Even so, astronauts like Buzz Aldrin and Neil Armstrong described how exhausting it was to move around on the moon in their suits. Each step was a challenge, and even gripping tools took significant effort. Fast forward to the modern era, and the challenges have only grown. Today's astronauts aboard the ISS rely on the Extravehicular Mobility Unit, EMU, a state-of-the-art spacesuit designed for extended spacewalks. The EMU is a marvel of engineering. It provides oxygen, removes carbon dioxide, regulates temperature, and even shields astronauts from space radiation. But despite all these advances, the suits are still not perfect. They are heavy, weighing over 275 pounds on Earth. They take hours to put on, and they are extremely difficult to maneuver in for long periods. In fact, astronaut Chris Hadfield once described the experience of working in an EMU as wrestling a gorilla. Every movement is met with resistance because the suit is constantly pushing back to maintain pressure. Now, let's imagine being an astronaut. You're floating in the vacuum of space, gripping the side of the ISS as you carefully tighten a bolt during a repair mission. The Earth spins beneath you at 28,000 km/h, a breathtaking view stretching out before your eyes. But inside your suit, you're sweating. Your fingers are getting numb from the stiffness of the gloves, and each movement requires deliberate effort. You have a limited oxygen supply, and you must finish your work before time runs out. One small mistake, a lost grip, a snagged tether, could send you drifting into the endless blackness of space. The stakes couldn't be higher, and it's not just astronauts who feel the limitations of spacesuits. Engineers on the ground are constantly pushing for new solutions to make suits more flexible, lighter, and more durable. In recent years, NASA and private companies have been working on next-generation suits designed for future Moon and Mars missions. The Artemis program, set to return humans to the Moon, has introduced the new XEMU, Exploration Extravehicular Mobility Unit, which, promises greater flexibility and mobility. Unlike the bulky Apollo suits, the XEMU allows astronauts to move more naturally, making tasks like bending down or picking up objects much easier. But perhaps the most exciting advancements are happening in the world of soft suits, suits that use mechanical counterpressure instead of traditional gas-inflated designs. These next-gen suits, inspired by research dating back to the 1960s, are designed to fit snugly against the skin, using elastic materials to provide the necessary pressure. Space exploration is a high-stakes endeavor of survival, innovation, and resilience. Some moments mark triumphant breakthroughs, while others remind us of its dangers. One of the most dramatic turning points in spacesuit history came during the 2013 spacewalk disaster of astronaut Luca Parmitano. The spacewalk that nearly ended in tragedy. On July 16, 2013, Italian astronaut Luca Parmitano, representing the European Space Agency, ESA, embarked on a routine extravehicular activity, outside the International Space Station, ISS. His mission was to complete maintenance tasks, inspect the station's exterior, and install new communication cables. Initially, the spacewalk proceeded smoothly. Parmitano and his partner, Chris Cassidy, worked methodically with only their own breathing and occasional radio chatter breaking the eerie silence of space. Below them, Earth spun in stunning contrast to the vast darkness beyond. Then, something went wrong. Parmitano felt moisture inside his helmet. At first, he thought it was sweat or condensation, but soon the water spread, creeping up his face. In microgravity, water does not drain, it clings, forming a suffocating layer. Within minutes, his vision blurred, his ears filled with water, and breathing became difficult. Realizing the severity of the situation, Parmitano reported, "I feel a lot of water on the back of my head." But even as he spoke, his radio started to cut out. The liquid was moving toward his nose and mouth, threatening to drown him inside his own helmet. NASA Mission Control had never encountered such an emergency before. The race against time mission control immediately aborted the EVA. Parmitano had to return to the airlock before the water completely obstructed his breathing. But navigating in space while effectively blind and deaf was daunting. With incredible composure, he retraced his steps by touch, following the handrails of the ISS. His breath grew labored as water edged dangerously close to his nostrils. If he lost consciousness, rescue would be impossible. Inside the ISS, astronauts Karen Nyberg and Chris Cassidy worked urgently to depressurize the airlock. Time was running out. Finally, Parmitano reached safety. As the airlock sealed, his crewmates rushed to equalize pressure and remove his helmet. A ball of water escaped, floating weightlessly. Parmitano, drenched but alive, gasped for air. The aftermath. Investigating the cause, NASA launched an immediate investigation. The culprit was identified: a clogged water separator in the spacesuit's cooling system. This caused water to backflow into the helmet, creating a life-threatening hazard. The incident led to major changes in spacesuit protocols: water-absorbing helmet pads to soak up unexpected leaks, snorkel-like breathing tubes to allow oxygen flow, even if the helmet fills with water, enhanced pre-EVA checks to detect potential issues before astronauts exit the ISS. Parmitano's near tragedy became a turning point in spacesuit design, highlighting unforeseen vulnerabilities in even the most advanced systems. A defining image photos of Parmitano's water-filled helmet became a chilling reminder of space's unpredictability. The incident prompted engineers to refine future suits, including the Artemis XMU suits for lunar exploration, which feature improved cooling and drainage systems. Lessons in resilience beyond technology, Parmitano's experience underscored the importance of human resilience. Despite near blindness and suffocation, he remained calm, trusting his training and instincts. His survival was a testament to astronaut discipline and preparation. Imagine the future: a Mars mission, a deep space EVA, an astronaut stepping onto an alien world. These explorers will wear suits built on the hard-earned lessons of past challenges. They will carry the legacy of Parmitano and those who have pushed the boundaries of human survival. Space exploration is not just about technology, it is about people. And every step we take beyond Earth is a testament to our enduring spirit of exploration. Space exploration is a high-stakes endeavor of survival, innovation, and resilience. Some moments mark triumphant breakthroughs, while others remind us of its dangers. One of the most dramatic turning points in spacesuit history came during the 2013 spacewalk disaster of astronaut Luca Parmitano. The spacewalk that nearly ended in tragedy. On July 16, 2013, Italian astronaut Luca Parmitano, representing the European Space Agency, ESA, embarked on a routine extravehicular activity, outside the International Space Station, ISS. His mission was to complete maintenance tasks, inspect the station's exterior, and install new communication cables. Initially, the spacewalk proceeded smoothly. Parmitano and his partner, Chris Cassidy, worked methodically with only their own breathing and occasional radio chatter breaking the eerie silence of space. Below them, Earth spun in stunning contrast to the vast darkness beyond. Then, something went wrong. Parmitano felt moisture inside his helmet. At first, he thought it was sweat or condensation, but soon the water spread, creeping up his face. In microgravity, water does not drain, it clings, forming a suffocating layer. Within minutes, his vision blurred, his ears filled with water, and breathing became difficult. Realizing the severity of the situation, Parmitano reported, "I feel a lot of water on the back of my head." But even as he spoke, his radio started to cut out. The liquid was moving toward his nose and mouth, threatening to drown him inside his own helmet. NASA Mission Control had never encountered such an emergency before. The race against time mission control immediately aborted the EVA. Parmitano had to return to the airlock before the water completely obstructed his breathing. But navigating in space while effectively blind and deaf was daunting. With incredible composure, he retraced his steps by touch, following the handrails of the ISS. His breath grew labored as water edged dangerously close to his nostrils. If he lost consciousness, rescue would be impossible. Inside the ISS, astronauts Karen Nyberg and Chris Cassidy worked urgently to depressurize the airlock. Time was running out. Finally, Parmitano reached safety. As the airlock sealed, his crewmates rushed to equalize pressure and remove his helmet. A ball of water escaped, floating weightlessly. Parmitano, drenched but alive, gasped for air. The aftermath. Investigating the cause, NASA launched an immediate investigation. The culprit was identified: a clogged water separator in the spacesuit's cooling system. This caused water to backflow into the helmet, creating a life-threatening hazard. The incident led to major changes in spacesuit protocols: water-absorbing helmet pads to soak up unexpected leaks, snorkel-like breathing tubes to allow oxygen flow, even if the helmet fills with water, enhanced pre-EVA checks to detect potential issues before astronauts exit the ISS. Parmitano's near tragedy became a turning point in spacesuit design, highlighting unforeseen vulnerabilities in even the most advanced systems. A defining image photos of Parmitano's water-filled helmet became a chilling reminder of space's unpredictability. The incident prompted engineers to refine future suits, including the Artemis XMU suits for lunar exploration, which feature improved cooling and drainage systems. Lessons in resilience beyond technology, Parmitano's experience underscored the importance of human resilience. Despite near blindness and suffocation, space exploration has often been a realm where human ambition meets technological limits, where triumphs survival was a testament to astronaut discipline alongside challenges that imagine technology and human endurance to the edge. A deep space EVA, few events in the history of space exploration an alien have tested the limits of technology as dramatically as the Apollo 13 on the hard-earned lessons of past challenges. What was originally designed as a routine mission to the legacy of Parmitano would soon become a race who have pushed the boundaries of human survival. Lives of 3 astronauts space exploration is not just about technology, forcing space agencies to confront a terrifying every step we take beyond Earth is a testament to our enduring spirit. Keep them alive during a crisis of this magnitude? The emergency oxygen reserves, one of the most critical features of the spacesuit, was the primary life support system, PLSS, which included an emergency oxygen supply. Each astronaut's suit contained a backpack with several hours of oxygen to sustain them in an emergency. Although the astronauts could not wear these bulky suits inside the lunar module due to the cramped space, they could still use the oxygen supply in their suits to temporarily alleviate the oxygen shortage in the lunar module. On Earth, Mission Control went into overdrive, scrambling to find a solution to this new crisis. The original CO2 scrubber in the lunar module was designed for a specific size and shape, but the engineers had to figure out how to fit a square CO2 filter from the command module into the round opening of the lunar module system. This problem, famously dubbed the square peg in a round hole dilemma, became an iconic symbol of the resourcefulness required during the mission. The solution came from the ingenuity of the engineers, who devised a makeshift filter using nothing more than the materials the crew had on board. Duct tape, plastic bags, and cardboard from the spacesuit's instruction manual were all that was needed. With these materials, the astronauts created a functional CO2 scrubber that worked just as well as the original. As the astronauts assembled the filter by hand, they were essentially inventing a solution that had never been tested before. The result was a success. CO2 levels dropped, and the astronauts were able to continue breathing. It was a stunning example of human ingenuity and the power of teamwork. The astronauts' spacesuits had played a pivotal role in allowing them to survive this crisis. Their life support systems, including the emergency oxygen supply, kept the astronauts alive long enough to carry out the improvised fix, allowing them to breathe until they could return to Earth. As Apollo 13 plunged into the atmosphere, the spacecraft began to heat up to nearly 2,700 degrees, 2,500 degrees. The astronauts experienced violent shaking as the heat began to envelop the spacecraft. The crew braced themselves, knowing that any failure of the spacecraft's systems would be fatal. But as they crossed the threshold of the radio blackout, they could do nothing but wait. The astronauts had survived. Their spacecraft descended safely into the Pacific Ocean, and they were recovered by a rescue team. Against all odds, the crew had made it home. How Apollo 13 changed spacesuit design. Forever, Apollo 13 was more than just a survival story. It was a wake-up call that revealed the limitations of space technology. It proved that even the most advanced systems could fail when least expected, and it highlighted the need for redundancy, improvisation, and preparation for any scenario. The mission had a lasting impact on how NASA approached space exploration, particularly in terms of astronaut safety. Space exploration has often been a realm where human ambition meets technological limits, where triumphs of human ingenuity and boldness take place alongside challenges that push technology and human endurance to the edge. Yet, few events in the history of space exploration have tested the limits of technology as dramatically as the Apollo 13 mission. What was originally designed as a routine mission to the moon would soon become a race against time to save the lives of 3 astronauts trapped in a damaged spacecraft, forcing space agencies to confront a terrifying question. Could their spacesuits and survival systems keep them alive during a crisis of this magnitude? Spacesuits are far more than just astronaut gear. They are the ultimate survival machines, protecting explorers in the most unforgiving environment known to humankind. A journey through spacesuit. Evolution. We've traveled through time, from the first crude spacesuits worn by early astronauts to the cutting-edge designs preparing us for Mars and beyond. We've uncovered how spacesuits create a miniature Earth, supplying oxygen, regulating temperature, and shielding astronauts from deadly radiation. The life-or-death stakes of spacewalking, including near disasters like Luca Parmitano's terrifying helmet flood. The pivotal moment of Apollo 13, where human ingenuity and a few rolls of duct tape saved 3 astronauts in a crippled spacecraft. The game-changing innovations of today, like NASA's XEMU suits for the moon and SpaceX's sleek new designs, every step forward has been a testament to human perseverance. But as incredible as today's spacesuits are, they are just the beginning. What's next? The future of spacesuit technology. As we set our sights on new frontiers, the next generation of spacesuits will need to be smarter, stronger, and more adaptable than ever before. The Moon, Artemis and the XEMU suit. The Artemis program is set to return astronauts to the Moon, but this time they'll stay longer. NASA's XEMU suit is built for the job, offering greater mobility. Astronauts can walk, bend, and climb without struggling. Dust-resistant materials to withstand the Moon's abrasive regolith. Interchangeable parts to customize suits for different missions. Mars, the ultimate challenge. A Mars mission will push spacesuit technology to its limits. The red planet's toxic dust, thin atmosphere, and extreme cold mean that traditional suits won't cut it. Scientists are exploring mechanical counter-pressure suits, lighter, more flexible suits that squeeze the body rather than relying on pressurized air. Self-healing materials to automatically patch punctures from micrometeorite impacts. AI-integrated helmets, offering augmented reality readouts of suit status, mission data, and terrain navigation. Beyond a future among the stars, what happens after the Moon and Mars? If humanity dreams of interstellar travel, our spacesuits will have to evolve even further. Imagine bioengineered suits that adapt to extreme conditions, using bacteria or living materials to regenerate oxygen, radiation-absorbing exoskeletons to protect against deep space cosmic rays. Wearable AI assistants, turning astronauts into walking supercomputers. Could these suits help us step onto a planet in another star system one day? Could they make humans a truly spacefaring species? The big question: are spacesuits preparing us for life beyond Earth? Every spacesuit innovation brings us closer to living beyond Earth. Right now, astronauts wear them to survive brief missions. But what if in the future, spacesuits weren't just tools, but essential parts of human life? Imagine colonists on Mars suiting up every day, just as naturally as we wear winter coats on Earth. Mining crews on asteroids, using high-tech suits to extract resources from space. Generations born in space, growing up with the knowledge that they may never need a suit on Earth again. Are we on the verge of becoming a multiplanetary species? Final thoughts. Your role in the future of space. Exploration space travel isn't just for astronauts. The technology we develop for spacesuits could revolutionize medicine, robotics, and even everyday life. From wearable exoskeletons that help paralyzed individuals walk again to self-healing materials for extreme environments, the innovations shaping spacesuits may change the way we live on Earth too. So, what do you think? Will the first humans on Mars wear mechanical counter-pressure suits or something we haven't even imagined yet? Could spacesuit technology help us colonize new worlds, or even survive climate disasters here on Earth? Let's discuss in the comments. If you enjoyed this journey through the history and future of spacesuits, don't forget to like, subscribe, and follow for more amazing space stories. The universe is vast, and we've only just begun our exploration. Until next time, keep looking up. The emergency oxygen reserves: how Apollo 13 changed spacesuit design forever.